In the ever-evolving realm of computer vision, the ability to accurately track objects within image and videos has become a crucial task with numerous applications. From surveillance systems to autonomous vehicles, object tracking plays a pivotal role in understanding and analyzing visual data. And when it comes to tackling this challenge in Python, one powerful tool stands out is OpenCV. OpenCV, short for Open Source Computer Vision Library, is a popular and widely used open source library that provides a plethora of functions and algorithms for image and video processing. With its comprehensive set of tools, OpenCV offers an extensive range of capabilities for object tracking, making it a go-to choice for researchers, developers, and hobbyists alike. The process of object tracking involves locating and following a specific object as it moves throughout a sequence of frames in a video or images. OpenCV leverages a variety of techniques to accomplish this task, including motion analysis, feature extraction, and machine learning-based approaches. These techniques enable the system to detect and track objects based on their appearance, motion, or even both. In this tutorial, we will delve into the fascinating world of object tracking using OpenCV in Python. We will explore various methodologies and algorithms, and if you love to watch these types of videos, please subscribe to our Simplilearn YouTube channel and hit the bell icon to never miss any updates from Simplilearn. So without any further ado, let's get started over to our training expert.
So hi there, let's start with the object tracking using OpenCV Python. So in this I have this folder. I have just opened this folder named tracking object. In this I have one folder named as DNN model. On that I have classes.txt. These are the person, bicycle, car, motorbike, the object you want to track. Okay, and there is one YOLO v4 CFG. What is YOLO v4 CFG? Okay, so CFG, this model definition files include network definitions, hyperparameters, and anchor settings. A template of this file can be found in the darknet or CFG YOLO installation directory. Okay, so this file must match the weights file, this YOLO v4 weights. So what is YOLO v4 weights? So like all other models in the YOLO family, the YOLO v4 model is used for object detection. Object detection problems are where you need to identify where particular objects are in a given image or video or in webcam. Okay, so these files I will put this in so these are the two videos in which we will detect the object, and I will put these DNN model files in a drive, and you can download the files from the description box below. Okay, so I will here start with the object detection. So here I will create a new file name object detection, okay, .py. Okay, so in this I will first import CV2. Okay, then import numpy as np. So we are using Visual Code Studio. You can use your favorite personal ID. Okay, so what is CV2? So OpenCV has a function to read video, which is CV2, video capture. We can access our webcam using pass0 in the function parameter. If you want to capture CCTV footage, then we can pass RTSP URL in the function parameter, which is really useful for the video analysis. Okay, so this OpenCV developer chose when they created the binding generators. Okay, so the module import, you can import the module using CV2 only, and this numpy as np. So np is nothing, we wrote numpy is in short form, and numpy can be used to perform a wide variety of mathematical operations on array. It adds powerful data structure to Python that guarantee efficient calculation with arrays and matrices, and it supplies an enormous library of high-level mathematical functions that can operate on these arrays and matrices. Okay, numpy adds support for the large multidimensional array and matrices along with the large collection of high-level mathematical functions. Okay, so let's proceed further. So here I will create one function name as object detection, so I can use it in the tracking file. Okay, so here I will write class I will write here object detection. Okay, so here def is used for the define of function. Init self weights path equals to dnn slash model slash YOLO v4. This file, okay, this file we are see where is the path of the file, and the dnn model folder there is one file YOLO v4 weights. Okay, dot weights comma cfg path equals to dnn model slash YOLO v4 dot cfg. Okay, so here I will write self dot nms threshold equals to 0.4, then self dot I will write here confidence threshold equals to 0.5. okay, then self dot image size equals to 608. So what is NMS threshold? So it is used for the object detection. We can easily process the images as well as the videos to identify the object faces, and this confidential threshold so it is a set of corresponding confidences, like a set of bounding boxes, you can say. A threshold used to filter boxes by confidences in this case. Okay, and these comes under the YOLO model. So moving forward, let's load the network here, and let's load the network. So I will write here network equals to cv2 dot dnn dot read net. It is a function of reading the network of cv2, the weights path, then cfg path. Okay, then here we will enable GPU CUDA. So for that I will write network dot set variable backend cv2 dot dnn dot dnn backend CUDA. Okay, then I will write here network, then dot set preferable target, then cv2 dot dnn dot, then again dnn target. Okay, then CUDA. Then this is nothing, we are just enabling the GPU CUDA. Okay, so here I will write self dot model equals to cv2 dot dnn and detection model net. Okay, so here I will write network. So moving forward, let's set the classes as a self. So self dot classes equals to empty array. Okay, it's self, and self dot load class names. Indentation error will come. So self dot colors equals to np dot random dot uniform, then 0 comma 255 comma the size will be 80 comma 3. Okay, these type of project you can use in your resume or on your project. You can showcase in your university or college. Okay, then self dot model dot set input params, then size equals to self dot image size, then self dot image size comma scale it to 1 by 255. Okay, so here we will load the class names. So for that I will write here df load class names self comma classes path equals to, where is the class path? So again I have to go in DNN model, then again class. Okay, so here I will write DNN model slash classes dot txt. Okay, then with open classes path into read format as file object. So for classes, class names in file object dot read lines, and we already know what is in the classes.txt. These are all the objects files. Okay, 80 objects. This is known as a coco 80 dataset, as you can say. So read lines, so classes class name equals to class name dot strip, then self dot classes dot append, it will append with the class name. Okay, then here I will write, just take care of these indentations in Python. Self dot colors then equals to np dot random dot uniform. Here I will give 0 comma 255 comma size equals to 80 by 3 Okay, then return self dot classes. So here I will write def detect, then self comma frame we will generate, then it will return self dot model dot detect frame comma nms threshold equals to self dot nms threshold. Okay, then I will write here confidence threshold equals to self dot confidence threshold. Okay, so let's create one more file of the tracking. So I will write now name here tracking dot py. So in this file I will import cv2. As we discussed, we know what is cv2, then numpy as np. We already know what is numpy from object detection import. What was the function name? This, let me copy it and paste it here. Okay, this, yeah. So import, okay, let me rename this as object detection, I guess, but it will work. Later on we can do. And here I will import the math function. So here first we will initialize the object detection to OD, to the shorted form. Then okay, then I will write capture. Okay, I will write capture equals to cv2 dot video capture. Then first we will try in this video or this video. Okay, so let's take first this pixels. So I will write here, you can take any type of video, pixels dot mp4. Okay, then here we will initialize the count. So count equals to 0, and the center points of previous frame equals to empty array, and then tracking objects equals to my bad, then track id equals to 0. Then here I will write the small function while true, then the rectangle or the frame equals to capture dot read. Okay, if you will pass here in this video capture, if you will pass here 0, it will open the webcam of your laptop or your PC webcam. And here I will write count plus equals to 1. Okay, if not, then break. Okay, so let me add the point for the current frame. So here I will add the center center points of the current frame. Okay, then here we will detect objects on frame. For that I have to write class IDs, scores, boxes equals to od.detect frame then for box and boxes x comma y comma w comma h. Let me write like this for the better visual than box. Okay, so here I will write cx equals to init then x plus width divided by 2. Okay, x-axis plus x-axis divided plus width divided by 2. Then here I will add c for the cy init y plus height, because y point will be like this from like this and axis will be like this. That's why we added the width to the x and the height to the y. Okay, divided by 2. So center points of current frame dot append to the cx comma cy. Okay, so here cv2 dot rectangle to the frame comma then x comma y comma x plus width then y plus height. Okay, then I will add one more 0 comma 255 comma 0 comma 2. And remember that only at beginning we compare previous and the current frame. Okay, only at the beginning. If count equals to 2, then for point in center current frame, for point 2 in center previous frame, then distance equals to math dot hyplot of pt2 0 minus pt 0 then pt2 1 comma pt 1. Okay, these are the points. So if I will write here, if distance is greater than 20, these are the 20 points. So tracking objects track id equals to pt. Okay, I will write like this. Yeah, and the track id plus equals to 1, or else then tracking objects then copy equals to tracking objects dot copy. It's a copy function. It will track and copy the particular object. Here I will add the center points of the current frame copy equals to center points of the current frame dot copy. Okay, then for objects id comma pt2 in tracking objects, then copy dot items. And object exits equals to false. Then for point in center, okay, when the point will be in center, then the center points of the current frame copy. Let me write it again. Okay, then here the distance equals to math dot hyplot pt2 0 pt 0. Then here I will write comma pt2 1 minus pt1. Okay, so here I will update the ID's positions. So for that I will write if distance is greater than 20, then tracking objects, then objects ID equals to pt. It's objects. Oh my god, what's happening? It's object ID pt. Okay, then object exist equals to true. It's true. And if point in center points to the current frame and center points of the current frame dot remove the point. Okay, here then continue if it remains the same. Okay, and here I will remove the ID which are the lost. So if not object exists, then tracking objects dot pop object ID. Okay, and here I will add new IDs which are found. For that I have to write for object ID dot pt in tracking objects dot items, then cv2 dot circle frame pt 5 comma 0 comma 0 comma 255 comma -1, then cv2 dot put text, then frame str objects id, then comma pt 0 comma pt 1 -7, okay, 0 comma 1. These are the all the width and the height values. 0 comma 0 comma 255 comma 2. Okay, then here I will write print the tracking object. Okay, print tracking objects. Then here I will write print the current frame of the left point, current frame left points. For that I have to write print center point show current frame, cv2 dot I am show that frame comma frame. Okay, and make a copy of the points. For that I have to write center points previous frame equals to center points current frame dot copy key equals to cv2 dot wait key, then 1. Okay, if key equals to 27, then break. Okay, so after that I will write cap dot release cv2. Okay, here I have to write capture cv2 dot destroy all windows. Okay, so the code is complete. Let's run this. Okay, it's running the OpenCV. Okay, so as you can see in our video, it is tracking the object perfectly by frame. Okay, slowly and steadily by frame. See, 1 2 3 4 5 6. Okay, it's a huge video. Okay, it's 4K video, maybe that is why it is stucking little bit, but it is reading on the basis of the frame by frame. Okay, let's try the another video. Here first I will kill the terminal, then I will change the name to 123.mp4 and I will run it. So as you can see, it is tracking in the right order Okay, see, it is tracking perfect. See, car is moving but it's tracking, and here all the points we have measured, that x axis, y axis, all it's coming. Okay, see, it's tracking perfectly. And if you want this full code, you can comment down the below, and I will update all the necessary files and the libraries in the description box below. You can download from there. So with that said, we have come to end of this video. If you have any question or queries, you can comment down below. Our team of expert will reach out as soon possible. You can check the course from the description box below regarding AI ML. And thank you for staying with us. Thank
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.